is the last section in chapter 2, which is section 2.3. It's a continuation of the chapter. The chapter is about graphing, describing data using graphs. We studied some graphs in section 2.1, other graphs in section 2.2, and we continue today in section 2.3 with 3 types of graphs. 2 of them may be new for us, and the last one, which is the Pareto chart, is just a special type of the bar graph. So it's not really new. Okay, let us start with line charts. Line charts, 2-dimensional charts. 2-dimensional means x-axis and y-axis. What do you see on the x-axis? You see the time on the horizontal axis. What do you see on the y-axis or the vertical axis? You see the variable of interest. Okay, so we have usually time as the first variable and some other variable. For example, sales changes with time, or whatever number of students in the university changes each year, for example. Okay, for anything that changes in time, actually, if the variable changes over time, if you remember, then it is called time series data. Okay, time series. So actually the line chart displays the time series data, okay, which, if you remember, changes over time, each month or monthly or quarterly or annually. We studied 2 types of data. We said that we have time series and we have cross-sectional data. For time series, every year, every month, every day, every hour, this is the time series. This kind of graph, the line chart, present the effective way or effective tool to present this data, the time series data. And it also enables you to talk about the trend, okay? Because you have a line, so you will see maybe a trend, upward trend or a downward trend, okay? So you can predict, you can talk about the near future using the line chart. This is an example. GB produces mobile homes. The owners are planning to expand the manufacturing facilities. To do so requires additional financing. In preparation for the meeting with the bankers, the owners have assembled data on the total annual sales. So this is the variable of interest, annual sales, total annual sales for the past 10 years. And this is the time. It is each year for 10 years. So in 2008, the total annual sales was 1,426 and so on. Each year, this is the total annual sales. So this would be on the x-axis, and this would be on the y-axis. Okay. Now, identify the time series variable. The time series variable is units sold, the sales. That's the time series variable. The annual sales changes over time. The maximum of these sales is 4,003. Okay, over 10 years. Over 10 years. Then we put the horizontal axis and the vertical axis. On the horizontal axis, we put the years starting from 2008. So this is 2008. This is 2009, and so on. And now we put the sales, the annual sales, on the y-axis. And to choose a unit of measure, you have to look to the data. So the maximum is 4,000, the minimum is 1,400. So you need a unit of measure from 0 to 4,000. So he chose here 500. So 500 is okay, is good. So each bar is for 500. 0, 500, 1000, and so on. Now let us put the points, plot the points. So in 2008, the sales 1,426. So in 2008, we go to 1,426. It's about close to 1,500. So we put a point here. And then the second year, in 2,900, we have in 2009, we have 1,678. So about 1,600 somewhere here. Okay. So this is the second point, and so on. And then we connect these points. We get a kind of line. This chart is called a line chart. Okay. So it will give you an upper trend here in this case. So you can imagine, the sales are increasing over years. So this is the line chart. The second type of graphs is called scatter diagram. Okay, we call it scatter diagram or scatter plot. What is a scatter diagram? It's again a two-dimensional graph of points, plotted points, in which we have two variables. In which we have two variables. The vertical axis represents values of one quantitative variable, and the horizontal axis represents values of the other quantitative variable. So you have two quantitative variables. You put one of the quantitative variables on the x-axis and one of the other quantitative variable on the y-axis. So the scatter diagram is a graph that display or represents two quantitative variables, one of them on the x-axis and one of them on the y-axis. Each plotted point has coordinates whose values are obtained from the respective variable. Okay, so the coordinates of each point, you get the x coordinates from the x variable and the y coordinates from the y variable. So this allow the decision maker to examine the two variables at the same time. Scatter plots. We examine the two variables at the same time. We are dealing with two quantitative variables. What would happen? One of the variables would be called the dependent variable. The other one is the independent variable. Usually, the dependent variable depends on the independent variable. If the equation, for example, is solved for y, if you have y equals a plus bx, for example, here x is the independent variable, while y is the dependent variable. Because if you change x, y changes. If you replace x by 0, you get ya. If you put x 1, you get ya plus b, and so on. X is the independent variable, y is the dependent variable. What would happen? Notice that this is called regression analysis. Okay, regression analysis. We will focus on, is there a relationship between the two variables? Okay, is there a relationship between the two variables x and y? So if you sketch the diagram or the scatter diagram, you will see things like this, a graph like one of these. Okay, for A and B, you can say that the points are in a linear pattern. They have linear pattern, شبيهين باللاين يعني, linear pattern. Part A in part A, it is an increasing line. It's a positive linear relationship between x and y. In part B, it's a negative linear relationship between x and y. What does it mean? When x increases, y decreases. while in part A, when x increases, y also increases. Okay, but this is positive linear relationship, this is negative linear relationship. If it is not a linear, some kind of curve, okay, some kind of curve, or you call it curve linear, either in C or in D. If it is like this, scattered without any relation, we say no relationship. There is no linear relationship increasing or decreasing in E and F. So this what would happen. At the end, he will ask you, interpret your answer, or what kind of relation is there. And usually, either you have a positive linear or a negative linear relationship. This is what we are concerned about. This is an example about scatter diagram. The owner of MD taxi service has selected a sample of customer trips and has recorded the data on three variables. The distance in miles, quantitative variable, trip duration in minutes, quantitative variable, tip amount to driver, also quantitative variable. To better understand this data, the manager is interested in knowing the relationship between trip distance and trip duration. So he would like to know the relation between the distance and the duration, and also between the distance and the tip, the person tip. Okay. To do that, we will do a scatter diagram for the distance and the duration, and another scatter diagram for the distance and the tip. So this is the first scatter diagram. The distance, we put it on the x-axis, the duration on the y-axis, because the duration depends on the distance. When you increase the distance, the duration should be increased. That's the usual thing we know, okay? The duration of the journey, well, of the trip, depends on the distance. Okay, so the distance would be the independent. So we always put the independent on the x-axis and the dependent on the y-axis. Now we choose a unit of measure for the x-axis and the unit of measure for the y-axis according to the data. You have to go back to the data. The distance would be on the x-axis to check this data. The smallest is 0.9, the largest is 13. So I need from 1 or from 0 to 13 or 14. You can go 1 by 1 if you like, 1, 2, 3 up to 14, or you can go 2 by 2. It is up to you. Here he chose 2. This is 0, 2. If this is 2, this would be 1. This would be 3, and so on. 1 to 0 to 4 up to 16. So this is the unit of measure for the distance. Okay. What about the other variable, which is the duration, the y variable, duration? We have numbers from 3 to 24. Okay, for here I need more numbers. It is up to 24. We can choose each 2, each 3. It is up to you. He chose here 5, 5. That's okay too. Okay, so let us start plotting the points. What is the first ordered pair? The first ordered pair would be 4.2. X is 4.2. So it's 4.2 and 7.9. So 4.2 with 7.9. So X 4.2, this is 4. So 4.2 would be about here. I go up to 7.9. So it's almost this point. This is the point representing 4.2 and 7.9. And so on. I do that for all of these points. For example, the point for 13.5 and 24.6. 13.5 is about here, and I go up to 24.6. So this is the point representing the ordered pair 13.5 and 24.6. And then I leave the points like this, scattered. This is what we mean by scatter. So there is no line connecting them. You do not connect the points on the scatter diagram. خلاص, you look now to the points and try to interpret. What do you see? I can see the relationship is linear, positive linear relationship. I can say it's a strong linear relationship لأنه الline is nice يعني. Okay. The other scatter diagram would be between the distance and the tip. So the tip, we would like to know how the tip changes with the distance. For the distance again is the independent, and the tip depends on the distance. For here, the ordered pair would be the distance 0.9 with 28. Okay, we take the distance with the tip. Well, the distance, again, I need a number from 1 to 13, so I can choose the same unit of measure from 2 to 16. For the tip, I have numbers from 10 to 28, so from 0 to 30 would be enough. Each 5 units, it's okay. So you can do it each 3, each 4, it's up to you. And now you take a point, for example, you put all the points, but for example, let us take 4.7, not 4.7, sorry, 1.7 and 20, 1.7 and 20. So this is 1.7, this is 2, so this is 1.7 with 20, so this point represents 1.7 with 20. There is a point less than 2, but let us check it. Where is that point? Yeah, 0.9. So there is a point 0.9 with 28. So you put 0.9. This is 0.9, 0.9 with 28. So this is the point 0.9 with 28. You put all the points. You do not connect them. And then you try to figure a relationship. Is there a relationship? I can see, it's somehow also linear, but it is not that strong. It is, of course, not strong like this one. It's weak linear relationship, and it's negative. So we can say that it is a negative linear relationship. Means as x increases, y decreases. I did not expect this. I expected, if the distance increased, the tip would be increased because the driver, maybe went more distance. But unfortunately, here the trip decreases as distance increases. We can interpret the relationship. The first scatter diagram shows a strong positive linear relationship between the distance and the time. In the second case, the relationship between distance and percentage amount tipped tends to be negative. We can see it's negative. So the longer the trip, the lower the percentage tip. The linear relationship in the second case doesn't appear to be strong as it is in the first case. That's what we see from here. طبعا, of course, there is in fact a numerical measure called correlation. Correlation between X and Y. We denote this measure by R. And there is a specific formula to evaluate this R, to find this R. And R is a number between -1 and 1. If it is closer to 1 or -1, the linear relationship would be very strong. So if it is positive, it would be positive linear relationship. If R is negative, the relationship would be negative. You can use your calculator to find R easily. You can go to mode 3 stat and number 2 a plus bx, and you put the values of X and Y, the distance and the duration. And you will find, please do that at home, you will find that R for the first, in the first scatter diagram is much closer to 1 than this R. I think this R could be 0.7 or 0.6. Check it please at home. While here it would be greater than 0.9, I'm sure, in in the first scatter diagram. So this will give you more indication and that's the relationship is linear and it's strong or not strong. The last part of the last type of graphs is the Pareto chart. The Pareto chart is just a special type of the bar chart. Okay, in fact, it's a bar chart organized from high to low. So the bars are organized. The bars are organized from high to low. So you start by the highest bar, and then the next one, and then the next one. This enables you, if you arrange the bars like this enables you to concentrate on the vital few. Vital few means the most important factors, okay? And you leave the trivial many, because sometimes you have a lot of factors here or a lot of types, and really the most important types are this one, the cracked edge, okay? The too wide, so you may be concentrating to solve these two problems, and then you will solve mostly all of your problems, okay? So you can concentrate on the highest bars. If you draw the bar graph like this, starting the bars from the highest to the lowest, this is called Pareto chart. In this case, we will call it Pareto chart, and here a historical note about this type of graph. Well, I leave two questions for you to solve. Question 246, it's about a line chart, okay? You have the months, you put the months on the x-axis, you put the sales on the y-axis, and each month in January you put 200, in February you put 230, and then you connect the points. This will give you a line chart. In 247, construct a scatter diagram. The dependent variable is y as usual. X is the independent variable as usual. So and check whether there is a relationship or not. So you put x on the x-axis, y on the y-axis, and you plot the points, and you do not connect the line. You see whether there is a relationship or not between these two variables. This is the end of this lecture. Thank you very much. And if you have any question, please ask.